Welcome to another deep dive. Today we're going to be looking at patterns and numbers, and it seems like you've got a knack for spotting a good sequence when you see one.
It's true. These problems you brought us are more than just, puzzles or brain teasers. They really get at the heart of some pretty fundamental mathematical ideas that are kind of hidden in plain sight all around us.
I love that.
Okay.
Okay, so let's just jump right in. This excerpt from Can You See the Pattern? Caught my eye. It talks about how you can take a simple block and use it to create all these intricate designs, like the kind of patterns you might see on a kurta or a skirt.
It's fascinating how just by changing the rules of repetition, even with the same basic shape, you can end up with such drastically different visual results. Like, imagine rotating a block a certain way each time you place it.
Yeah, it's like how a single musical note can be the starting point for an infinite number of melodies, depending on how you repeat it and arrange it with other notes.
Exactly. And this idea of repetition with variation, it pops up everywhere. We see it in art, like with those amazing tessellations by M.C. Escher, where shapes fit together perfectly to create these intricate tiling patterns. And nature's full of them too, of course, from the structure of a honeycomb to the unique symmetry of every snowflake.
Speaking of patterns in nature, are you ready to put your own pattern recognition skills to the test?
Always up for a challenge.
Okay, so this book has some really fun practice problems. Like, imagine a block that's turning by 45 degrees with each rotation. What would the next rotation look like? Don't overthink it, just trust your gut.
These exercises, they're not just for fun, although they are fun, but they actually help us develop our spatial reasoning, which is something we use all the time. Whether we're designing a building, navigating a new city, or even just trying to pack a suitcase efficiently.
It's really incredible how these seemingly simple patterns have such far-reaching implications.
Yeah.
And speaking of which, let's shift gears a bit and talk about those magic squares and magic hexagons you included.
Ah, yes. Those examples offer a glimpse into, the fascinating world of numerical relationships. And while they're called magic, the true magic really lies in the inherent order and properties of numbers themselves.
They're kind of like numerical puzzles, right? Where you have these squares and hexagons filled with numbers, and the trick is that each row or column has to add up to the same specific number.
Exactly. And what's so interesting is that this concept of magic squares, it's been around for centuries, popping up in ancient cultures all over the world. It speaks to this, this kind of timeless human fascination with finding hidden patterns, even within something as seemingly rigid as numbers.
It's amazing how certain mathematical concepts transcend time and culture. Okay, so are you ready to roll up our sleeves and tackle a magic hexagon problem together?
Let's do it.
This one here looks particularly interesting. This hexagon, in particular, it's got me intrigued because instead of just adding numbers, we're dealing with multiplication.
Yeah, it definitely adds another layer, doesn't it?
It does. So we've got these hexagons, and on each side there are two circles and a box. And the idea is that the numbers in the circles, when you multiply them together, they have to equal the number in the box next to them.
And you know what's interesting about that? It actually highlights this really important principle in multiplication called the commutative property.
The commutative property. Remind me what that is again.
Sure. Basically, it means that the order in which you multiply numbers doesn't actually change the outcome. So 2 times 4 is the same as 4 times 2. They both equal 8.
Oh, right. So even though we're working within these specific patterns and rules, there's still that flexibility in how we approach the multiplication itself.
Exactly. It's not about memorizing a rigid set of steps. It's about understanding these underlying principles.
I like that. Okay, are you ready to give this hexagon a try and figure out what numbers go in those empty circles?
Absolutely. Let's take a look.
Okay, so let's see. Where should we start?
Well, we could start by focusing on the sides where we already have at least one of the circles filled in. That'll give us a starting point.
Good idea. All right, I'm already starting to see some possibilities here.
Me too. And remember, it might take a bit of trial and error.
That's part of the fun.
Eh.
Now, this next section, it's all about palindromes. I don't know about you, but there's something so satisfying about a word or a number that reads the same backward as it does forward.
It's true. There's an elegance to them. Race car, madam, 1001, they just have this inherent balance.
And you know what's really cool? They're not limited to just language and numbers.
That's right. They pop up in all sorts of unexpected places, like DNA, for instance.
Really? Tell me more about that.
Well, certain sequences of DNA, they actually read the same backward and forward. And this palindromic structure, it plays a really crucial role in how genes function.
Wow. It's like nature's using this elegant code to organize and replicate genetic information.
Exactly. And, we even find palindromes in music. Composers have been using them for centuries to create symmetry and balance within their pieces.
That's amazing. Okay, so we've got palindromes in language, genetics, music. It's everywhere. And in the examples you provided, there's this fascinating explanation of how you can actually take a regular number and turn it into a
That
palindrome.
is like a numerical game.
You take a number, reverse it, add it to the original number, and you just keep repeating that process until you end up with a palindrome.
It can be surprisingly addictive. Some numbers transform quickly, while others might take a bit more work.
So it's like a numerical treasure hunt.
Precisely.
Okay, you ready to try one?
I'm game.
All right, let's start with the number 43. So first we reverse it, which gives us 34. Then we add those two numbers together, 43 plus 34.
Which equals 77.
And there you have it, a palindrome.
See? Sometimes they reveal themselves quickly.
That was almost too easy. I'm ready for a challenge. What happens when we encounter a number that doesn't transform so easily?
Well, that's where the real fun begins. We just keep applying those steps, reversing and adding, and eventually that palindrome will emerge. It might take a few iterations, but the journey is just as interesting as the destination.
Speaking of journeys, let's move on to this next section. It's all about odd numbers and something called smart adding. I'm always up for learning a new mathematical trick.
Me too. It keeps things interesting.
So this section points at this really cool pattern that happens when you add consecutive odd numbers together.
Oh, right. Like 1 plus 3 equals 4.
Exactly. And then if you keep going, 1 plus 3 plus 5, that equals 9.
And 1 plus 3 plus 5 plus 7 equals 16.
Do you see what's going on here?
Ah, yes. It creates a perfect square every time.
Exactly. The sum of consecutive odd numbers always results in a perfect square.
It's such an elegant pattern, isn't it?
It is, and it reminds us that math is full of these hidden connections. But before we get too carried away with the beauty of perfect squares, let's actually put this knowledge to use. This source material mentions something called smart adding, right?
It does, and it's a great example of how understanding these patterns can actually help us solve problems more efficiently.
So did you manage to crack the code and find the sum of all the numbers from 1 to 100 using that smart adding trick?
Well, let's break it down. Remember how we talked about pairing the numbers to make use of those handy sums?
Yeah, like 1 plus 100 equals 101.
Exactly. And then 2 plus 99, that also equals 101, and so on and so forth.
Right, right. So we end up with 50 pairs in total, and each pair adds up to 101. Okay, I think I see where this is going.
Instead of adding all those individual numbers, we can just multiply 50 by 101.
Which gives us 5,050.
You got it. 5,050.
Wow, that's way faster than I would ever thought to do it. It's amazing how these patterns can simplify things. Okay, so before we wrap up this deep dive into the world of patterns and numbers, there's one last little section here that I wanted to touch on. It's called secret numbers and number surprises. What makes these numbers so special?
I think this section really highlights how math can be just as much about the journey as it is about the destination. It's like you can use these simple operations, doubling, adding, multiplying, dividing, and combine them in a specific sequence to create these almost magical outcomes.
So it's like a mathematical recipe that always leads to a surprising result.
Exactly. Like one of the examples here, it tells you to take any number, double it, then multiply by 5, and then divide by 10. It seems like you'd end up with a completely different number, right?
It does. But knowing that it's supposed to be a number surprise, I have a feeling there's a catch.
There is. Because if you think about it, multiplying by 5 and then dividing by 10, that's basically the same as just multiplying by half, which cancels out that initial doubling.
Oh, wow. You're right. So no matter what number you start with, you always end up back where you began.
Exactly. It's like a magic trick, but with numbers.
I love it. It seems magical on the surface, but when you break it down, it's pure logic.
Precisely. And I think that's what makes math so fascinating. It's full of these seemingly magical properties and relationships, but when you understand the underlying principles, it's even more awe-inspiring.
I could agree more. Well, I think that about wraps up our deep dive for today. We've explored patterns in shapes, we've uncovered the magic within numbers, and we've even discovered some hidden connections between seemingly simple concepts. It's been quite a journey.
It has. And if there's one thing I hope our listeners take away from this, it's that math is so much more than just memorizing formulas and equations. It's about exploring patterns, making connections, and never being afraid to ask why.
Beautifully said. And on that note, we'll leave you to ponder the wonders of the mathematical universe. Until next time.